I can well imagine when they were practicing, they were taking the cameras and the magazines home because they were responsible for developing their own film while they were practicing so that they could review them themselves.
Well, they got pretty good because they don't use a viewfinder. They're not using a viewfinder. How are they doing this? How are they getting all these photographs just right on the money like this without a viewfinder? I've tried it. It's not possible. You know how many pictures you have to take? You have to bracket and bracket and bracket till the cows come home.
You have 60 astronauts that were being trained. If they went out on a training mission to practice with the cameras, and even if they were using a magazine in the morning and a magazine in the afternoon, and they trained them for 6 weeks, okay, you got several thousand magazines. NASA doesn't want to catalog those. So these guys are going to keep that equipment. I mean, the way they toss equipment around, they could care less whether it's a $25,000 Hasselblad camera or not. The guy take it home with him. Part of his training program. Everybody else got Corvettes. They were cheaper than the camera.
It's interesting that none of those pictures that the astronauts allegedly took on their holidays or on their barbecues or at the family home, none of those seem to have appeared online in the last 20 years.
Yes, and where are any of the so-called practice on their simulation set? They would match exactly the set that we see on the final version. That's why.
That's why, yeah, exactly. They don't dare show them because it would just blow the whole thing wide open.
That would be something else, right? And then you have all the other technicians that are doing those lunar orbiting shots, right? Working on all of those practice shots. Never mind what they're claiming for the final simulation or whatever they're doing there. If you had those magazines where they were practicing on the globe and everything else, they would look exactly like what you're seeing on that magazine 42 there.
Of course they would.
42 and 43, any of the orbital shots, they're going to look exactly the same because they are the same. And they probably used all of those magazines and simply taken the best shots that they could get from all of those magazines off of there and put them on a magazine.
Here's a shot of Neil Armstrong, Buzz Aldrin, and Michael Collins, and their hands are being held out towards this model moon. And it looks so real when you zoom up on that. I mean, this is highly detailed.
Yeah, they got that 5-foot model as well, right, that they were photographed behind, right? And then they got a 20-foot model. And then they've got all the 10-foot panels of the different pieces. You see all of those shots of all those different panels just being packed up there. And then you see the camera in on the arm with the little feeler gauges to keep it just off the surface when they're doing the flybys and stuff, right, when they're mapping it. I mean, if they could say, these are the ones that we shot those images with, but here's the real ones as we orbited the moon, and we could see the difference. We'd have to be able to see the difference between what they did in their so-called simulation and what they claim to be real on the moon, and they're not going to show those because they are the same.
Yeah.
One and the same.
Those model moons, you know, the 20-foot model that we see in the pictures, that was created from the lunar orbiter photographs, which is a reasonable thing to do. I mean, if you're going to go to the moon, nobody's been there before. They haven't been there since, but that's another story. You want to know what things are going to look like. So you take the photographs, which they did, create the plaster of Paris models, so they know what they're going to, and then photograph it. And that's what you see.
You could do pretty good mapping, considering what we have for telescopes, even in the 1960s. I mean, you could map the moon pretty well just using a telescope, because you could get right in and see a hell of a lot of that detail and map it right out. And then, of course, then you go to Flagstaff, and then you have Yoko Amato did the surveying. Of course, he would have taken those maps and surveyed out where they did the blast craters as well. He would have been the guy doing that.
Yeah, because that whole scene at Flagstaff, Arizona, in Cinder Lake, they used those lunar orbiter photographs to create what became the Apollo 11 Sea of Tranquility site. I mean, you can see that the two are very, very similar. the size of the craters, the positioning of the craters in Arizona matches pretty closely what we was shown of the Sea of Tranquility. Not when Armstrong was on it, because that had to be done later.
Plus the fact you've got Armstrong didn't land exactly where they were going to land in their simulation, in their storyboard. He didn't land where he said he was going to land. And not only that, you have 3, 4, or 5 different landing sites available for each of the moon landings. So you couldn't possibly have a cue card with the stations available because you have no idea you're going to land there.
Yeah, exactly.
Why are they even carrying that piece of equipment with them? They do not know where they're going to land. They had at least 5 alternate landing sites for the missions, and that depending on the countdown, the windows that were available open to launch. If they missed the launch and took off, they're going to be on a different landing site because of all of the other orbital mechanics that are involved in it, right? And I mean, somebody worked all of that out, where they're going to end up, the position of the moon when they take off from, when they're going to arrive, and how they're going to land on there. It's going to be in a different spot. So the cue cards are probably the biggest thing. That is the storyboard on which they're working with. And it would only work if they landed in the location that they claim they're going to land in. And I mean exactly the location, because the measurements, how many minutes it takes to get to Station 1, is dependent on the fact that you land exactly in the spot that is located already with an X on the cue card, exactly where you're going to land. And that storyboard has to follow in line, and all the timing and everything else. Well, none of that was designed for the moon. All of that was designed for their practice at Flagstaff.
Yeah, exactly.
The cue cards are drawn up months ahead.
It was a nice touch to put those retro rockets in silhouette in the photograph, because obviously they were on the moon, obviously because this is part of the lunar lander. The retro rockets, the little 4-nozzled control rockets on the side of the spacecraft. So obviously they're there, because why would they put, it's a very nice touch, that. Very easy to do it. You know, silhouette as well, not that.
Magazine 42-910, they could have taken that off of a photograph off of a telescope, that particular image, rather than one of their maps. But the difference being is you see the radial lines coming off of the thing, and that's what you're going to get when you look through a telescope. You're actually going to see the radial lines coming off the craters. You don't see that in these other ones, like these ones, this plaster molding, right? There's no radial anything coming off, and they should be very detailed at that point. These are taken from images from a telescope, definitely. Those radial lines.
I have another one here with Armstrong, Aldrin, and Collins over that globe, and they have perfectly mimicked that lighting, where you see all of these striation lines, I guess. I don't know what you call them, but you see all those lit up lines.
They've done that because they basically photographed the image right onto those little globes, right? That's what you see. Why only those 2 images? We're on magazine 43. All of a sudden it changes to this.
Yeah, first they were high, and now they're low again.
Yeah. Now we're on a plaster mold. Very distinctly a plaster mold on magazine 43 here, as you go through them. Like, look at that. Where are the radial lines there? Anywhere.
Yeah, good point.
They were flying over impact zones where you could see them. And now you're a lot closer. Now, mind you, now that they have every lens available. They didn't have them when they went there, but 50 years later, now they have them. Robert's got the entire list of all of the lenses they had available. They had an entire Photoshop worth of stuff. Every different kind of film available to them, and it's all listed here on March to the Moon, all the different ones available. None of them are special. None of them are hardened for space. None of them were stored in lead cases with Faraday cages around them to transport them, which they would need to have so they wouldn't be damaged, and they would have to be pressure and temperature controlled at the same time, transportation. These images here are just a mix-mash of everything that they were trying to do to create a simulation on an orbit.
But of course, one point that they seem to overlook, rather, is that if you're in orbit around the moon, what speed are you traveling at?
6,000 miles an hour.
How come none of these images have any blurring or lack of definition? You'd think that you get a few of them, wouldn't you? Because you're taking them with a camera that's got no viewfinder. So you don't actually know what you're photographing. The thing is moving at 6,000 miles an hour, 50 miles above the surface, and it's not blurred. All right, so it's quite bright if it's on the moon.
And they're shooting out a window. People claim you get a double image when you shoot out the window, so that should really blur it.
Of course you get a double image when you want it. You know, if you don't want it, there's no double image.
You can only get the double image on a reflection. Can't get it shooting through because it's a transparent. If you can shoot through the transparency and see it, both layers of glass are shooting the same way. These craters, for being 60 miles up there, are much higher than anything on Earth. Things are probably 20 miles high, these crater ridges. They're just incredible. Like, I'm just shooting through here on the different stuff, you know. Like, you take the back of a pencil and you stick it into some plaster, and that's what you get right there. The size of that crater with no radial lines whatsoever on the impact. There's absolutely no indication. We've just been looking through 30, 40 photographs here, and we have not seen a radial impact of any kind, way, shape, or form. No other disturbances on the surface other than the little depressions in there. Here's one that's tried to get a little bit of white on it, but there's still no radial impacts on anything. And then you get this, shooting around the far side of the moon. And then, of course, all of a sudden, everything changes again. The lighting changes, everything has changed here. And then back to it again. There's the next photograph, right back at it. There to there. There's a little bigger attempt, still no radial impact on it. This one just looks a whole lot fresher than these ones. But there should be radial lines out. Just a shame that they didn't have the technology in the 1960s to do a better job of this.
Because they didn't know that 60 years after they created them, somebody was going to be examining them in far more detail than they even thought necessary. And because they didn't get the detail right, as you say, the radial lines from the impact, if those are supposedly impact craters, I don't think they are. I think they're electrical discharge craters. I mean, that's the sort of impact that an electrical discharge crater will produce. It'll have a flat bottom, a flat base. A big discharge crater will have a flat base and no central peak because there's nothing to come up. But nobody's ever looked at the idea that they could be electrical discharge craters. Some of them are impact craters, that's for sure, but not all of them.
No, and don't forget that without any moisture, without an atmosphere, without anything else, just traveling through space on its own, the entire moon is going to be electrified. Even back in the early 1900s, they were talking about the photoelectric charge that levitates the fine dust and brings it a few kilometers off. That entire ball of dust that is rising up off of there a couple of kilometers is a full electrical charge in itself. That's what's suspending it.
Yeah.
When you encounter that, if you were landing down through that, you're liable to get a huge electrical discharge on the machine that you're landing with. It's going to take out all of your electronics. This particular image, being quite different than these other ones, looks like it was taken from a telescope as well. You can see the radial lines on there. These ones are. And then back to this again, right? You don't see anybody featuring these lines. I was looking at this one a while ago, and look at this. Looks like they rolled a big bowling ball down here, because that looks like it just bounced, but you don't see anything down here, right? Something skipping across the surface, making an entire line going in there. If you're 60 miles off the surface, that's well over 100 miles across. And there it is again. There's that line again.
It's extraordinary how so many of them have such flat lighting. It's as if they stayed in one place all the time to photograph flat lighting, because they knew that if there was going to be shadows cast by craters, in fact we don't see very many hilly areas. We see flat, basic stuff. It's so boring and tedious.
Yeah, well, what I see is the backside of a number 2 pencil, the eraser side, and just going ding, 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 all the way across the plaster mold. That's what I see.
Yeah, because they're all basically a plaster mold, you know, but they didn't do a very good job of it.
No. Oh, look, it's got, even when you get down to here, there's a big one there, but they all go straight in. So how do you get from here to there when they're all dropping straight in? If it was skipping along, or if it was rolling, it would be a continuous.
It's the luck of Apollo, isn't it? More luck of Apollo. It's had more luck than anybody else.
But look at the rocks that come out of craters and then roll across the surface for miles. They just come right out of the craters and start rolling. I mean, we've seen that photo.
Uphill.
Yeah, and uphill.
But when you start looking at these different images, I have no idea what that is.
I don't think they did either. They're so flat, they're so featureless, it would appear to indicate that these photographs are taken on the far side of the moon. But they don't really show very much. I mean, they're so featureless and boring, you wonder why they bothered. But they couldn't do very much to enliven them, could they? Without showing up the joins. Or it was just another way of filling up the catalogue with lots of different photographs. So what's it showing? Longitude
84 and latitude 10.5. But you have to decide which North Pole they're using, whether they're using the celestial North Pole or the original mapping of the North Pole where we see the moon and they put the North Pole at the top and the equator across for us to look at. And the other one, the North Pole, is directly in the center of it where it's rotating. How do you know where the landing sites are with coordinates if you don't know which North Pole you're using? Of course, they didn't come up with the other North Pole until some guy said, hey, the rover's got a compass on it.
It's basically to confuse everybody. I mean, they can put those figures up that are 90 degrees whatever or 6 degrees whatever, and it looks like it's all technical and it's all correct, but as you say, unless you know what you're measuring from, you don't really know where on the moon to look for that image. Because one of the most prominent features on the lunar surface is the Copernicus crater, which is slightly to the left of center. It's a very prominent crater. But I don't see any pictures of that. It's so prominent and it's so obvious, one would be able to identify it almost immediately. Same with the Tycho crater.
The rover had a dial on it with northeast, west, and south, and they used it as a sundial. And it had a little stick in the middle. It was sitting on the dash, and you pull it up level, and then you lift the little stick up in the middle, and you know which direction the sun is coming from. So you dial that around. If the sun's coming from the east, you dial that around on the dial so that it's facing east, or the shadow of the stick is pointing to the west. And then you can do your directional coordinates wherever you are driving around on the thing. But in one of the documents from NASA, somebody mentioned that it was a compass. And now you need to have a magnetosphere, which means you have to have a proper orbit to create that. You know, you're going to end up with a magnetic belt field. If you have a magnetic field like that to run a compass, you're going to end up with something similar to the Van Allen belts.
The moon doesn't have a dynamo in it.
It doesn't have any of that to create that kind of energy. But because they made the mistake on the rover, and somebody said that it was a compass instead of a sundial, when they corrected it, they didn't know what a sundial was, so they call it a sun shadow device.
You know what a sundial is? I mean, they've been around for centuries.
That's right, but the young gentleman, whoever it was that was creating the documents, did not know what a sundial was, so he called it a sun shadow device when they updated the PDF file on the rover one more time. And then on top of that, they added a computer to the rover just using the rotational wheel speed and direction of the wheels. And don't forget, you got four-wheel steering. They claim they have a computer in there that reads the speed and rotation of each of the four tires. And based on the direction while you're driving around, it'll tell you how to get back to the length. Information is displayed up on the dash, and it takes over the odometer on the dash to show you how far you are away from the limit at any given point. except these are cable and gear driven things. The odometer is a cable and gear driven device that can only count forward when you're driving forward, or it counts backwards when you're driving backwards, the same as an old speedometer on a car. It all of a sudden isn't going to be able to display the information you want, the direction that you need to head back to the LEM at, how far you are away from it at any given point when you're driving around. And the computer, so-called, is located underneath a pack for the TV camera right on the front frame rail of the rover. You got that mylar foil, you got the flaps that come off the batteries, right? And then you've got that pack that's running down there for the TV camera that sits on the front rail just in front of the batteries, on front of the rover. And they claim that this computer sits just underneath that on the frame rail. Now, this computer, to be able to do that kind of tracking, plus you'd need to have towers up for it to map everything out for your GPS to triangulate it. They're claiming they're doing it off of there. I would imagine in 1969, the size of the computer that would be needed would be probably the size of a public school.
There's no way that they can claim GPS, Global Positioning System, because they didn't have the orbiting satellites to provide it on the moon.
They claim that the rotation and direction of the tires, because when you turn a corner, your inside tire is turning at a slower speed in the direction, that this computer can calculate all of that to show how far they are away and the direction they're away.
Yeah, I mean, that's called dead reckoning. It was an old navigational tool centuries ago.
Yeah, but they're calling it a GPS. And not only that, there's no way to display it on the dash.
I can understand that they're going to need coordinates to get to where they're going, but when they get there and they want to get back, why don't they just follow the tracks?
Being that they're the only ones there, they can follow their own tracks back. And on top of that, they have to be within visual range of the LEM at any given time because their communication is line of sight. So if they couldn't see the LEM, we wouldn't be able to listen to them talking because their communication is line of sight. And of course, they can claim that it was coming off of the high gain antenna on the rover, but not while they're moving.
Yeah, exactly.
Okay, you'd have to like stop, get off the machine, call the guy to come over and line up your antenna for you, because these guys with those heavy gloves on, they're not going to be able to do that. And you're 240,000 miles away from where you're trying to line it up is bad enough to line up a satellite on the ground. The accuracy you have to get a good signal to get your satellite television in there, right? You got to call the guy for that to get it dialed in. You imagine how long it would take? You'd be into micro arc seconds to be able to line that up. Like if you were off by even a quarter of an arc second, you wouldn't be able to hit anything. And then it's going to change all the time because the Earth is rotating. The antenna you're trying to attach to on Earth, the Earth is moving at 1,000 miles an hour, right? So you got to have a guy there. It's got to be able to track it.
The ground tracking station has the motors in it, so that's not a problem.
Yeah, but it's moving. If you're sending the signal from the moon to it, the one on the ground is moving, so the one on the rover's got to have a tracker as well.
Why don't we put an appeal out to all those knowledgeable NASA proponents and ask them to explain it? No, come on, NASA proponents, explain how this wonderful system worked. And just one question to start, NASA proponents. What angle of sight was required between the moon and the Earth? If you're going to communicate to the Earth, you have to have it within certain parameters. What are those parameters? And as Scott has described, if you get it slightly off-center, you're communicating with Jupiter, which isn't going to help. You've got to communicate with Earth. Now, Earth is a relatively small planet relative to the distance you're talking about here, 240,000 miles from the Earth to the moon, and you're trying to communicate through a dish about 2 foot in diameter. How accurate do you have to get that dish pointing at Earth to ensure that you're going to get communication?
If you sat in the seat, you'd lose the signal, even if you got it lined up. Take the equipment off. Just touch the rover in any way, shape. Load your rocks on there. Change your camera up. kick the dust off the wheels, whatever we see in the photographs, right? When they're knocking around in that, and they never lost communication at any bloody time. They have the TV camera running at the same time. They're doing that. Not just their audio, just not their voices. It's all running. Just touch that machine.
Just a few changes of direction doesn't take much.
Throw snowballs at your bloody satellite dish and see how long it takes for everybody in the house watching to come out and tell you to screw up.
Yeah, it can be affected by heavy rainstorm as well. Get enough heavy rain, that's liquid, by the way, rain, liquid, that can affect a TV signal. And that's only coming from 25,000 miles out. Geosynchronous satellites, not very far. What we're talking here is 10 times that distance, 240,000 miles. How did they do it? It's more the luck of Apollo. And as you say, there was no drop of signal, there was no loss of voice communication when they were supposedly talking live. The luck of Apollo held right through those missions.
I think the best way to describe that is to take one of those little laser lights, line it up, 500 feet down a city block or whatever, and then pick it up in your hand and see if you can hit the same spot while you're walking and keep it on that spot.
You can't do that. It'll move. It'll move around all the time.
That's at 500 feet. Now just do that over 250,000 miles and see what happens, right? That's the problem with the communication and signaling that they had while they're doing that. And not to mention the amount of energy it would take to push that signal.
Which is all coming from batteries, by the way. All the power to drive that signal out coming from batteries. It's more the luck of Apollo.
Not to mention the fact that when the photoelectric charge builds on the dust on the lunar surface, it's going to levitate up in the air, and then when the sun goes away, all of that dust is going to land back down on top of those solar panels, and they're going to be completely useless. They're going to land on top of the laser reflector.
Yep.
They're going to land on top of everything, and of course, they're going to cover over the so-called permanent footprints that are on the moon. So even if you came by today, you wouldn't see them. Even if they did exist, you wouldn't see them because of the 50 years of the levitation of the lunar dust from a photoelectric charge caused by the sun.
Scott, don't spoil a good story. NASA need to have the basic information. They don't mention the dust because that would cover the footprints. So don't spoil the story for them.
But they associate with scientists that have mentioned the dust and written articles up long before NASA existed.
If it doesn't fit the narrative, it's not there. It's fake news. It didn't fit the narrative, so it was just taken out.
Well, maybe they'll bring it back up when they can't find any footprints when they get there, and they'll say, oh, it was the levitation of the dust.
Same as the blast of the lunar module taking off was so powerful it knocked the flag over because they put the flag too close to it.
And of course, there's going to be a fairly large meteor strike on
Right.
Apollo 11 site, Apollo 12 site. They're all going to get hit. It's
Yeah.
landed in the wrong spot. We need to have a meteor strike on each of the locations so that it's no longer visible where any of the equipment is. Or a coronal mass ejection that is so powerful that it literally melts the aluminum off the craft that's left there, just obliterates it.
Maybe that explains why the Chinese Space Agency could only say they identified traces of Apollo following the meteor strike. So there's a few bits of aluminium lying around, and those are the traces of Apollo they'd identified.